Good morning, students. In AI, Unit-3, Knowledge Representation. In this Unit-3, today I start the topic Computable Functions and Predicates. Okay. Here we can take some functions and we can predict or we can guess the output of that particular functions. Okay. To express simple facts such as the following greater than and less than relationship. Here we can give the simple facts like greater than and less than. In greater than there are three facts are given: greater than 1, 0, greater than 2, 1, greater than 3, 2. Now in less than relationship, less than 0, 1, less than 1, 2 and less than 2, 3. Three different facts are given. Okay. Now we can use the computable functions as well as computable predicates. Okay. So we might want to evaluate the truth. Now we can find out the truth. What truth? Here the truth is given greater than 2 plus 3, 1. Okay. Means we can combine these two simple facts and make the results. Okay. Now to do so requires that we first compute the value of the plus function given the arguments 2 and 3 and then send the arguments 5 and 1 to greater than. Now we can find out the values for the plus function. Okay, in plus function we use the greater than 3, 2 and we can use the argument 1 and 5 for the greater than. Argument 5 and 1 means in above example we can take the arguments. Okay. Now we can consider the following set of facts again involving Marcus. We can take the previous example Marcus. Okay, first is Marcus was a man. So we can write the sentence like this: Marcus is object. Because here the person name is Marcus and it is a man. So we can write this simple fact like this: man in bracket Marcus. Now second is Marcus was a Pompeian. We all are know that man is a person and Marcus was a man and Marcus was a Pompeian. So we can write this sentence too like this: Pompeian in bracket Marcus. Okay. In first man in bracket Marcus we can write. Now in the second sentence we can write this simple fact: Pompeian in bracket Marcus. Okay. Now the third simple fact is given: Marcus was born in 40 AD. Okay. Marcus was born and which address is given. So we can write this simple fact like this: born Marcus, 40. Okay. we can simplify the all sentences. Okay. Now 4 sentences, all men are mortal. So we can write the fourth sentence like this: for all x to man x to mortal x. Okay, man is Marcus and Marcus is Compian, and here we can use the another man's and they are mortal. Okay. Now we can take the different facts. All Pompeians died when the volcano erupted in 79 AD. All Pompeians are died means they not alive. When volcano is erupted in 79. So here we can write these simple facts like this: erupted in bracket volcano comma 79, and here we can use the and symbol, and for all x Pompeian x to died x comma 79. All Pompeians are died, and Pompeian is a man and man is Marcus. So we can write this fifth sentence like this. Okay. Now the next simple fact is no mortal lives longer than 150 years. It is the basic thing and which is given in the simple facts. So we can write the simple facts like this: for all x where all t1, all t2, mortal x and born x comma t1 and greater than t2 minus t1 comma 150. Here we can write this because our limit is given 150. Any person or any mortal can't live greater than 150. Some are live 149, 140. Okay. So here we can write t2 minus t1 comma 150 and died x comma t2. Okay. t1 and t2 both are different variables, mortals, and we can take these mortals and find out its age. Now next simple fact is it is now 1991. So we can write the simple facts like this: now is equal to 1991. Okay. Above example shows how these ideas of computable functions and predicates are useful. Okay, we can take the previous simple facts and find out the computable function and predicate functions, how we can use this function and write the simple facts into simple ways. Okay. Now it is also makes use of the notation of quality and allows equal objects to be substituted for each other whenever it appears helpful to do so during a proof. In maths we can use the proof, and here we can also use the proof and make the different sentences. Okay, and find out the different objects which are connected with the proof. Now we can take as a suppose we want to answer the question. Suppose we can make one question: is Marcus alive? Okay, and we can get the question's answer. So we use the computable functions and predicate logic here. So this statement suggested that two ways are possible. Marcus was died or Marcus is alive. Okay. So either we can show the Marcus is dead because he was killed by the volcano. He was killed in the volcano. Okay. So it is died. And in another condition we can take as it is died because no one can alive greater than 150 years. Okay, these two possibilities are given. Now, as soon as we attempt to follow either of those paths rigorously, however, we discover just as we did in the last example. Now we can attempt or we can find out all the possible solutions and or all the possible questions and find out the questions answer. Okay. So here we can take, for example, our statements talk about dying, but they say nothing that relates to being alive, which is what the question is asking. What is our question? Is Marcus alive? Means Marcus is alive or it is died. Okay. Two possibilities are we can predict from the given question. So here we can add the following facts. Facts 8 and 9. Alive means not died. Okay. And we can write this sentence like this. For all x, all t, alive x comma t2, not dead x comma t and not dead x comma t2, alive x comma t. The person is alive. Okay. And second is if someone dies, then he is dead at all the later times. Person is died or it is alive. Two possibilities. In first possibility we can take as it is alive, and in second 9 we can take as it is dead. Okay. So we can write for all x, all t1, all t2, died x comma t1 and greater than t2 comma t1, dead x comma t2. We can find out all possibilities and then we can choose the particular result. So for the question is Marcus alive, here one diagram is given. Not alive Marcus comma now. Now Marcus is not alive means he is dead. So we can write this example like this. We can start with the nil, then greater than 1991, 79. We can compare the age by its year, born year. Okay. Then we can find out greater than now, 79. We can substitute which solution is possible. Then Pompian, Marcus and greater than now, 72. Marcus was the man and it is the Pompian. So we can write here and we can find out its age. Then if it is died, then died Marcus comma t1 and greater than now comma t1. We can substitute the possibilities and find out the question's answer. Okay. Now if it is that, then Marcus comma 9, now it is the another possibility. So we can find out the another possibility, and we all are know that it is Pompians are not live greater than 150 years. So we know that it is died. So here we can write not allowed Marcus comma now. Now Marcus is died or dead. Okay, it is not allowed. So this is the example of computable functions and predicate. So today I complete the topic computable functions and predicates of AI unit number 3. Okay, next lecture I will start the next topic. Okay, thank you.